Hello everyone. In last lecture, we have talked about the purpose of geometric correction. We also learned under what situations we need to do geometric correction ourselves. We have learned three geometric correction methods: the image geometric correction, based on the position information of sensors, suitable for modest level 1 data, and the image geometric correction with GLT file for FY3 data, and image-to-image registration for landside data. This lecture, we will discuss the last geometric correction method, called image-to-map registration. This method is suitable for the image data that does not have the correct geometric coordinates, but we measured several points in the image. Similar to the image-to-image registration method, the image-to-map registration using ground control point to establish a converging function and convert all pixels of the image to obtain the correct pixel coordinates. The difference between the two methods is that in the image-to-image method, the actual coordinates of the control point come from another standard or reference image. But in the image-to-map method, the coordinates of the control points come from field measurement. Before starting the image-to-map correction, we need to add some special coordinate systems to ENVI. Okay, please navigate to the image geometric correction, data, image-to-map, and coordinate. We need to use this for file to replace the map projection folder in your ENVI installation path. For my computer, it is likely in the C program files, Eclipse ENVI, and classic map project. You need to use this for data to replace the data in your installation folder. So we need to copy this and paste and replace them all. Then restart ENVI. The purpose of this replace is to add and define the coordinates which is necessary in this exercise. Okay, when you finish that, we can operate image to map correction exercise now. First, please open the practice data named TAIANDRG.TIFF. We need to find the data image geometric correction data image to map and open this one TAIANDRG.TIFF. Press open. And if we open the data manager, we can find this file do not have spatial coordinate information. Okay, let's do the geometric correction for this map. From the toolbox, select geometric correction and registration, and find the geo-registration image to map. Then we should to select image display bed. We select a combination of RGB bed GB to display, then click OK. The image to map registration dialog appears along with 3 window display group. In the select registration projection list, we need to select the output projection or enter a custom projection type. Here, we choose the Beijing 1954. We find Beijing 1954 GK Zone 20. Okay. There is a lot of map projection. We need to choose this one because our map, this is a map which is produced by this projection coordinates. So we need to choose this one. And we need to enter the X and Y pixel size. Here we enter the X and Y pixels size. We define them 4 meters and click OK. Then the ground control point selection dialog appears. This dialog, this tools, is the same as the control point selection tools. in image to image registration. And in this section, we will interactively define ground control points, the GCP, using zoom window of the display group. And in this display group, we need to locate the first kilometer network interaction in the upper left corner. We need to find this interaction. And choose this point. We can read the X is 20501 kilometers. So we need to fill in the ground control point selection panel E and N. So here we need to enter 20501 kilometer. So we need to press 30 to transform them to meter. Similarly, the N value is 4003 kilometer. So we need to enter 4003 kilometer. And click endpoint. Okay, this is the first ground control point. For this grid, it is 1 kilometer. In the display view, we need to pan the map 10 kilometers to the right. So we need to find 10 kilometers. We need to find this one is 11. So we need to choose this point and press 205 and 1 and 11 kilometers. And the N is the same to the last point because they have the same Y value. So we can change this data, this number, and press endpoint. Okay. And then we need to pan 10 kilometers to the 21 and find this cross and press and enter 21 kilometer and click endpoint. Okay, we can show the list. When 3 points are selected, the Predict button lights up. You can enter coordinates in E and N. Click the Predict button to automatically position it on the graph, such as if we want to go to the point south 10 kilometer, so we can enter 399 and predict. Okay, it cannot predict in the real or the correct position, so we need to choose more control point. And this is the first grade. Is 2501. To press this 01 and find the 339. This is 4000. We need to choose. If we choose this one, the grade, or if we choose this grade, it should be this. No, this grade. It should be 395. Zero. This point should be 3995 kilometer. And press and point. This is the 4 ground control point. Then pan 10 kilogram. And find sorry, we need to find this one and pan them to south 10 kilometers. Might be this one. And the coordinate must be 2511 kilometer and press and point. Okay, we can show the list. We can find the RMS is very little. And we have 5 control points. Then we can predict, such as we alter the number to 2005, 21, and predict. Okay, we can predict with a little bit shift, but we can choose this point and press and point, and we finished 6 control point. Okay, and then we need to find more control point. At least we need 9 GCP. So here we need to press 95, might be 88, and predict 88. This should be this point, and this changes this number to 1. The predict the way to rear and point, and change this to 0. Predict. Okay. And point. Then we got 9 control point. We can alter point by error, and we find the IMS, the largest IMS is 1 pixels, more than 1 pixels. We can delete it or update it, but for saving the time, we will not alter this anymore. Okay, we can save the control point to ASC file, such as we can save this 9 control point to the file folder, the RS data image geometric correction and image to map, and temp makes my GCP is press OK. Or we can save if you do not choose the control point yourself, you can directly import the 9 selected control point from file, restore GCPs from ASC, and find this one, GCP point PTS, and press OK. Then we will get, I need to delete the control point first, so we need to delete them all. We need to clear it and file, restore ground control point from ASC, and choose this one, GCP point PTS. Then we can get 9 control point. With at least 9 control point, we can perform geometric correction on the image. On the ground control point selection panel, select Options, Warp File. Then we need to choose the image Taian DRG point TIFF as the input warp file, then press OK. OK and click OK. In this dialog, we can select the coordinate system of the output images and select the correction model. Here we set the output projection as the Beijing 1954 GK-ROM20 and set the warp method to IST. For the resampling method, we choose BioNaner or nearest neighbor is OK, both of them. And the background value set to 0. Then choose an output folder. Enter a file name to output. I need to this one. Image to map warped Tai'an. I give the name Tai'an 2 and press open. Press OK. Okay, we can close the GCP selection panel and the 3 window. This is the TIFF data have been geometrical correction. To verify the result of the image to map registration method, we can open a reference file from File, Open Word Data, and find this one, Countries, for comparison. And choose Yes. Okay. The zip file named Countries have been opened. We can right-click the countries file and choose Zoom to Layer Extent. We can find this is the country, the boundary of every countries. It is a standard files with the projections WGS84. So this is a file with correct coordinates, and we can find that because the data before correction, the data, the Taiwan DRG pointive data has no coordinates, and the display of this file error even exceed the global scale. We can find with the latitude, we can find the latitude and longitude in the left corner. You can find the latitude become 700, so it is obviously uncorrected. By right-click the corrected data, this one, projected and warped TAIN, and right-click it and choose this one, zoom to layer extend. We can find this is the warped Taiwan 2 TIFF data. And if we choose this one, we continually click the zoom out button, continually click this button, we can find this image. This is the image appears in the eastern part of China, Tai'an City, and Shandong Province. Okay, it has a right coordinate system. By right-click this data and select View Metadata, we will find that this data already has a standard projected coordinate systems, and it can be used as a reference data. Okay, this is the content about the image to map registration. The reason why we can do the geometric correction for this data, because we can read zoom to layer extent, we can get the real coordinates from this map. So it is important input parameters for image to map registration tools. This is the image to map registration. Next, we will practice the very simple but very important tools named image spatial subsetting or spatial clip. The purpose of image spatial subsetting is to remove areas outside our study. The commonly used method is to clip images according to the boundaries of administrative divariance or natural divariance. ENVI images spatial subsetting tools allows us to clip a large scene, a large picture down to a manageable size using either the spatial extent of another file as guide or a user-defined area or the bounds of region or a vector shapefile. Here, three spatial subsetting methods will be used, named regular image subsetting, image subsetting from ROI, and image subsetting with external vector data. The first one, regular image subsetting, refers to that the boundary of the output cropped image, the output clipped image is rectangle, and many ENVI tools allows us to subset our data. And here we will learn one of them. Okay, first we need to close the data we didn't use and open the data at 3 image subsetting and choose the Beijing TM point DAT. We can string it with liner 2%. We can find this is a TM image at Beijing. We can choose the file, save as from the menu bar, and choose the data type we need. Here we choose the ENVI standard file type, and in the file selection dialog we can perform the spatial and the spectral subsets. We can use spatial subset to limit applying a function to a spatial subset of an image. Click this button. The image we choose to subsetting will display on the right, and we can string it. The red dotted line indicate the output range of the image, which includes the full image by default. We can enter the starting and ending rows and columns here to specify the output range For example, we can enter columns from 500 to 800 and rows from 100 to 900 and click OK. Then we can choose the file folder we want to save. Choose the data, image subsetting, and save to the subsetted TM data point DAT and press OK. Okay, this one is the subsetted data. We can string it. Okay, once again, there is something else preference we need to learn. Save as the Beijing TM and spatial subset. In addition to direct input numbers, we can also draw a rectangle box with the left mouse button to define the output range. In addition, we can use the range displayed in the main window as the output range, such as if we zoom in to the Forbidden City, and then restart the Save As tools, choose the Beijing TM, and open the Spatial Subset. Then we press this tools. We can find the output range as current displayed range. We can also input the real coordinate range to limit the output range from the enter map coordinates tools. As long as the data has corrected coordinates, we can find this data have the projection named UTM zone 50N. We can enter the plane coordinate range in meters or spherical coordinate range, such as longitude and latitude range in degrees. Again, it should be noticed that this requires that the data has correct coordinate informations. Okay. Here we use current view extent to subsetting this image. And moreover, we can use the spatial subset tools here to output one or several bands as a demonstration. We choose to output the first three bands. We need to choose the first one and press Ctrl or press Enter or press Shift to choose the first three bands and click OK. Click OK. After that, we choose the output path, substitute view range, and press OK. If we zoom out, we can find the data have been subsetted correctly. It should be noticed that the file input and output paths should be kept in English as much as possible, because ENVI's support for other languages is not as good as English. If the path name, for example here, the path name is in a language other than English, such as Chinese, the software may report an error and the subsetting will not succeed. Okay, after talking about regular image subsetting, let's talk about image subsetting from ROI. Okay, ROI is the short for region of interest. And first, we will introduce how to build, how to get a region of interest file. Okay, in the first lesson, we learned about that how to create a ROI. We need to click the ROI button on the toolbar, or or click on the file name in the layer manager and select new region of interest. After region of interest tools appears, we can click the left mouse button to draw the area of interest. After drawing a figure, right-click to select Complete and Accept Polygon, or double-click with left mouse to complete the ROI creation. Right-click the ROI that has been drawn. We can edit, copy, and delete the ROI. In the region of interest tool panel, we can modify the ROI's name, such as this is the Forbidden City, and we can change the color of this ROI. After the drawing is completed, we can save the ROI as an external file for future recall using File, Save As. We can save the ROIs to a .xml file, such as we choose my ROI 2. Press OK. This is the ROI file restore. The ROI file save. This is the XML file. At the same time, the old version of ENVI, for the old version of ENVI, the suffix of ROI file is .ROI. So if we want to save as an earlier version of the ROI file, we can use the file export and export to classic menu. And here we can find that the output file suffix become .ROI. Okay. After drawing a ROI, we can use it to clip the image. From the toolbox, select the region of interest and find subset data from ROIs. When this window appears, we need to choose BeijingTM data as the input file, and the Spatial Subset via ROI parameters dialog appears. We need to note that an available ROI is already populated as an input ROI named FB. Click this file name to select it, or alternatively, click the Select All Items button to highlight this file, and the number of items selected should become 1. Next, we need to change the mask pixels outside of ROIs to yes, and enter a mask background value. If we enter 0, the output background error is likely to be displayed as black. If it is set to 255, it will usually be displayed as white. Finally, select an output path. The subsetted from RI DAT, then click OK. We can find this is the data be subsetted, and the background value and the background value is 0. In addition to use RI to subset the data, we can also use external vector data to subset the image file. We can use the file open and open the zip file, find the subset RI point SHP and press open. Okay, this is the vector data. From the toolbox, also select subset data from RIs and choose the Beijing TM as input file. Click OK. Then choose the vector data EVF subset RI point SHP and set the mask output side of RI to yes, and set the background value. If we set it to 255, then set an output path subset from vector and press OK. Okay, this is the data have been clipped from the zip file, and the background data is 255. Well, these are all the content we need to learn in this class. To summarize, in this lesson, we learned the last method of image geometric correction called image to map registration. There, image to map registration. In addition, we also learned 3 different image subsetting methods. Use file, save as, for regular image subsetting to produce to get a image with a rectangle, with the shape of rectangle. And 2, we choose the image subsetting from RI. And 3, image subsetting with external vector file. In the following course, Mr. Zhang Yazhen will explain to you some other ENVI remote sensing image processing method, and she is an expert in the field of remote sensing, and I believe you can learn more useful knowledge of RS image processing from here. That's all. Thank you.